Hello everyone, this is Dr.V.V. Kamesh, Professor of Mechanical Engineering, Aditya University, Surampalem. In this lecture, we will continue our discussion how to draw the displacement diagram when the follower is moving with cycloidal motion. The learning outcome for this lecture is, at the end of this lecture, student will be able to explain about displacement, velocity and acceleration diagrams when the follower moving with cycloidal motion. Earlier we discussed about the displacement, velocity and acceleration diagrams when the follower is moving with constant velocity, simple harmonic motion, constant velocity or uniform velocity, you can call it as uniform acceleration and retardation. Three different motions we discussed. This is the fourth one when the follower is moving with cycloidal motion. So, these are the diagrams actually we need to draw with displacement, velocity and acceleration on the y-axis and the angular moment on the x-axis. See how to draw this when the follower is moving with cycloidal, right? What is the cycloidal? Actually, cycloid means there should be one rolling object. So, this is rolling object. The object is rolling on a surface, right? So, I am writing here, this is the surface, right? Why we are drawing the surface is with uneven, the surface is to be identified three different. One is a straight surface, convex, concave, right? So, in general, the plane cycloid, we are selecting a straight line surface. That means on a road, there is some tire, okay. So, the vehicle, we are having tires. The tires are moving continuously on the plane surface, right. So, when there is a plane surface and a circular object is rolling and at the end we are identifying the same roller again. So, it is rolling, after that finally it is reaching a point. Now, let it be when I am taking one particular point, suppose the bottom point is some P I am taking, after some rounds, right, after some rounds again the P is at the bottom, right, again the P is at the bottom, right. We do not know how many rounds, okay. It may be 2 rounds or 3, we do not know, right. So, after traveling some distance, again the P will be at the same point. By this, what is the distance covered? The distance is obviously when the P will be again at the bottom touching the road, the total circle is covered on the road. That means it is the one perimeter is completed on the road, right, then the P will be again at the same point, okay. So, this will be called pi into d. If the diameter of this one is small d, after covering the perimeter, the P will be at the same point. Now, what is there the cycloid? The cycloid means the locus of the point P for each and every moment, right. It is not the 100% rotation. By the time it is roller is moving like this, where the P is newly placed somewhere, right. So, when this is moving a slight movement to the right side, that means a small rotation, maybe 5 degrees or 10 degrees, actually it has to rotate 360 degrees. Suppose I am taking the locus of the point P for every 5 degrees rotation, then the P will move slightly, right, deviating from the original position, right, and after 10 degrees, 20 degrees, 30 degrees, 80 degrees, 90 degrees, finally by 360 degrees, the 360 it will be again touching the road or plane surface, right. Now, if you identify the locus of the point P at every instant, right, instant of the angular moment, then we need to join the locus of the point P so that it will come again like this, Okay. Now this blue color arc, sorry, this is not arc actually, it is looking like that. Now you need to call this curve as, because this is moving on a plane surface, you can call this as plane cycloid, right? If this is the first one, you call it as a cycloid, right? Now I told you the surface, if it is moving, right, to other item, it is convex, right? So based on the this one, you can call it as a epicycloid or hypercycloid, right? So if it is the convex surface, the roller is moving like this, right? When the roller is moving, the point will trace a curve like this. Then this is, you can call this as epicycloid, right? So like this, you can identify the cycloid motion. This is only the introduction. What is meant by cycloid? Right? Now, how to draw the displacement diagram when the follower is moving with a cycloidal motion? That means it is tracing the points on a curve when the curve is representing the path of a cycloid, right? Now you can start with C. So we need to start with actually on the x-axis the angular moment, and on the y-axis we need to identify the displacement. Okay. So on the x-axis and y-axis, whatever you are identifying, generally here it is the whatever the angle we are moving in the outstroke or return stroke, right? Uh, so we are dividing this into some parts, and we are identifying some starting point and ending point here if it is ascent, right? If it is descent, in the reverse way, okay. Now we need to trace some points in between, okay, in between, right? Suppose I am taking, this is capital A, this is capital B. We need to identify some points between A and B so that we are tracing the path of a cycloid, okay. We can start with, so in the right hand side diagram you are seeing the velocity and acceleration diagram also. Forget about the velocity and acceleration at this instant. Just you look at the displacement diagram. Actually, it is to be initially free, just like this. Okay. So this is the starting. So we are with blank rectangle, right? So the angle, that is theta O. Theta O means outstroke. Okay. Theta O. So AC will be maybe 90 degrees or 120 degrees, some angle will be given to us. So AC will be fixed. And what is the displacement actually? It is S. What is the S? Follower moment. In case of the cams, the straight line is a stroke of the follower which is the translating, and the circumference of the rolling circle is equal to the stroke of the follower, right? See, we already discussed, it is a rolling, right? Rolling on a straight surface, right? So rolling on a straight surface means, what is the distance travel? It is equal to pi d, right? What is this? 2 pi r, okay? So the distance that is traveling, traveled by the follower, right? So this is the follower distance, shall we call like that? Okay. So the follower distance is 2 pi r, okay? Generally, we are calling the follower distance with this name, stroke of the follower, right? So, what is the moment of the follower? So, the distance travelled by the follower is the stroke of the follower, S. Right? So, S is equal to 2 pi r, right? Now, what is the radius of the that particular invisible roller circle? S by 2 pi. So, whatever we are actually placed earlier, now you can see this. Here I had drawn the diagram in a horizontal way, but the follower is moving in a vertical way. Follower is moving in a vertical way, right? So, in the vertical distance, the maximum distance the follower is covering is S. But what is the diameter of the invisible roller? It is S by 2 pi. Okay. Now, how to draw the displacement diagram in a horizontal way, right? Because we need to divide the angle into some equal parts, and we need to identify the intermediate point, so that we need to trace the curve between A and B. Okay. Now what we need to draw is, in this, draw a circle of the radius s by 2 pi with A as center. So in your rectangle, you see at the starting point, you look here. So this is actually the starting point. So I am making with the pink color. This is point A, right? Now at the A, we need to draw a circle. Even though we are calling the invisible circle, we need to draw it, right? So what is the radius of the circle? S by 2 pi. Okay. Now we need to divide the circle into any number of equal parts. Generally, it is convenient for us to divide into 6 equal parts. If it is not divisible by 6, you make it with 8 or 10 or 5, okay, right. So generally we are taking here 6 points, right. Now project these points horizontally on the vertical line of the circle. These points are shown as A dash and B dash, okay. Now you can see in this, right. So this is what the point A, and I am drawing a circle here. Now I am dividing the circle into some parts. So I am dividing this into some equal parts, right. What are those equal parts? Clockwise I am taking one. This is, so these points we are not taking. So this is, so these are the lines of division, not exactly proportionate, you identify. This is part 1. Okay, for your understanding, I am hatching with this color. So this is one part, second part, this is the third part, fourth, this is the fifth part. So like this. Okay, I am dividing into 6 parts, right. Now, what is most important here, project these points to horizontally onto the vertical line of the circle. What is the vertical line of the circle? This is vertical line of the circle. That means this line, okay. So whatever the points you are having, 1, 2, 3, 4, 5, 6, you need to project onto the vertical line, right. So the 1, 2, you project it, 3, 6 already the center itself, 4, 5, right. Now how many points you identified? 1 point here, center point is already there, and here. Because the center point already named as capital A, now we need to name the points of the intersection 1, 2 intersected the center line at A dash, right. Okay, if we are having some confusion with the notation, you can call it as P dash and Q dash, no problem at all, okay. Shall we call P dash and Q dash? Okay, so this is P dash, this is Q dash, or with the notation A dash and B dash, no problem at all, right. So after identifying these 2 points on vertical line, what next? What we need to do is, now divide the angular displacement of the cam during the outstroke into the same number of equal parts. Actually, we divided into 6 equal parts the circle. The AC, that is maybe outstroke 90 degrees or 80 degrees or 100 degrees, 120, something will be given to us, theta O. That theta O is to be divided here, let it be 6 equal parts, right. So draw the vertical lines through these points. So we are drawing, yeah, I will draw this with the green color, right. So these are the lines with the green color, okay. So we are dividing the theta O into 6 equal parts. Now join AB diagonal, okay. So I joined AB, okay. Now we are having the rectangle is there, okay. So I draw with the yellow color the total rectangle. So till now we are having only 2 cycloid points, one is A, one is B. In between I don't have anything, right. Now join AB which intersects the vertical line through 3 dash at C. What is 1 dash, 2 dash, 3 dash, 4 dash, 5 dash? The 6 dash will be equal to C on the angular displacement parts, right. Okay. Now we have another point here, C. A is one cycloidal point, B is one cycloid point, C is another cycloid point, right? Cycloidal curve, I mean, right? Now, from what next? From A dash, draw a line parallel to AB, A dash or P dash, whatever you call, right? Now, this is, now I am putting with the green color, right? So, I need to draw a parallel line. That means a parallel line parallel to AB, right? So, with the mini drafter, we can draw like this, right? So, this line is cutting 1 dash and 2 dash, 1 dash and 2 dash vertical lines at 2 points. One is A, one is B. Okay, I got 2 points, right? Similarly, right? There is another point, Q dash or B dash you can call. From Q dash, you draw another parallel line. You draw another parallel line, right? So, this line is cutting other side. What is the other side? 4 dash vertical line and 5 dash vertical line at another 2 points, right? Actually, you can name the points with A, B, C, D, E, some number, right? Alpha, beta, gamma, whatever you like, right? So, here we are not naming abruptly. We are making A, B, C, D, E at, right? Or because this is the cycloidal points, you can call them as already C is there, right? So, you can make small C1, C2, C3, C4, C5, anything, right? Okay. Now, after identifying these points, you need to join with them smoothly. Now, this curve is our actual cycloidal curve. So, this is join A, B, C, D, E, B by smooth curve. This is the required cycloidal curve for the following during outstroke. So, after identifying the points, you can draw like this. Is it clear? Now, this is actually the displacement diagram. The same fashion we drawn with the uniform velocity, uniform acceleration and retardation and simple harmonic motion. So, the curve will be traced. After the curve is traced for the displacement diagram, we need to go for velocity and acceleration, right? Now, the velocity and acceleration, the curve will be different from earlier moments. Now, you can see here, the theta is the angle through which the cam rotates in time t seconds, and omega is the angular velocity of the cam, and theta is the angle through which the cam rotates in time t seconds. Now, the displacement of the follower after time t seconds, x is equal to s into theta by theta o. Theta means angle through which the cam rotates in time t seconds. Theta by theta o minus 1 by 2 pi into sine 2 pi into theta by theta o. This is the displacement equation. Now, how to find the velocity? Velocity is obviously velocity equal to ds by dt or dx by dt, whatever you call, right? So, after the differentiation with respect to the time, it will come like this, s into, because it is with respect to the t we are doing, d theta by dt, theta o is a constant, minus 2 pi by 2 pi theta o into cos 2 pi theta by theta o into d theta by dt. Now, you need to replace the d theta by dt, right, with omega. Finally, we got the equation like this. So, the curve will trace cos curve, okay. Now, we need to identify when the velocity will be 0, when the velocity will be maximum, right, depends on the equation. So, the velocity will be maximum, you can go, right. So, this part, omega is a constant, s is a constant, theta o is a constant. Now, how the velocity is dependent on the parameters? It is only the cost component. Because this is in the minus, when this will be the maximum in the positive side, when this will become minus 1, right. So, the velocity is maximum when cos 2 pi theta by theta O is equal to minus 1, right. When the cos will be minus 1, the first value, it is cos pi. So, 2 pi theta by theta O is equal to pi, or you can make theta equal to theta O by 2. That means at the middle, right. So, when theta equal to theta O by 2, we have the maximum velocity of the follower during the outstroke, then it will be 2 omega into S by theta O. So, VO is 2 omega S by theta O. So, this is maximum velocity, or you can make Vmax, right. Now, in the return stroke, the maximum velocity of the follower during the return stroke will be Vr is equal to 2 omega S by theta R. Why you didn't derive the second time? Because this is the same thing. This is the same thing, right? So, the equation derivation part will be the same thing. The only thing is the theta is changing. If it is the outstroke, it is moving like this. If it is the downstroke or return stroke, it is moving like this. Anyway, it is following the motion of a cycloid. Now, the acceleration will be dv by dt, or you can make d square x by dt square. So, you can make the displacement to 2 times differentiation, or you can make the one differentiation with respect to the time, the velocity, right. So, the acceleration of the follower after time t seconds, it will be d square x by dt square. So, whatever you are having the velocity here, the velocity, right. So, this velocity you take it and you make it differential. Now, this will be omega s by theta naught. You look in the velocity equation, omega s by theta naught or theta O, right. So, this is constant. Now, I need to differentiate only the term in the square bracket. 1 minus cos 2 pi theta by theta O, 1 is a constant, 0, and cos component. Now, I need to differentiate only this part. Now, after differentiating, I got cos will become sin, sin will become cos, but the sign will be changed. So, 2 pi theta O constant coming outside, sin 2 pi theta by theta O into d theta by dt. Now, obviously, the d theta by dt will be substituted with omega. Now, the omega s into omega, finally, it became 2 pi omega square s by theta O square into sin 2 pi theta by theta O, right. Now, you need to make this d square x by dt square when it will be maximum. So, 2 pi omega square s theta O square. So, this part will be constant. So, this is constant. Now, when this will become maximum, sin component will become plus 1. When sin will be 1, sin 90 degrees is equal to 1. So, this is equal to pi by 2. Now, the theta equal to theta O by 4. So, this is the condition when your acceleration will be maximum. So, now substitute this value sin 2 pi theta by theta O is equal to 1. Finally, AO 2 pi omega square into S by theta O square. So, make the sin component equal to 1. So, the remaining part is 2 pi omega square into S by theta O square. The same thing you apply to the return stroke. AR is equal to 2 pi omega square S by, instead of writing theta O, you write theta R. So, this is maximum acceleration in the outstroke and return stroke, AO and AR. The summary of this lecture is student learned about the displacement, velocity and acceleration diagram, the cycloidal motion, the motion of the follower. Thank you.